village is yours, Mr. Spock. Welcome, welcome. That's where that stupid intro comes from. So I've thought of 3 different electric motor designs. So there you go, thinking again. And the code name for one is Square Deal, and that should be a high torque pulse motor. Second is MagRamp, and it's kind of self-explanatory that there would be a magnetic ramp. And the third is the one that we're going to be designing today, which is Serpentine Window Motor. I want to provide just a little quick background, because I think sometimes I jump into these things where it's like some obscure thing that I just read a little while ago, and I just like dive into it like everyone or anyone knows what the hell I'm talking about, including myself sometimes. So the window motor is a motor design that was invented and popularized by the inventor John Bedini. It is identical, except for the fact that it has electrical commutation, to the Big Eureka machine of Joseph Newman, which was popularized as well in his book, The Free Energy Machine of Joseph Newman. Both of them have an orthodox avant-garde kind of way of arranging the electromagnetic windings for the coil in relationship to the permanent magnets. And when you look at it, both of them go directly back to the original experiments of Oersted and Ampere, where they're showing when you have a current flowing like that and say a magnet coming out like that it drives the magnet in an orthogonal or right angle direction. And so that's really what they're doing with the window motor, the Eureka Joseph Newman machine, and the zero force motor. The other part of this is a commenter on the channel here made me aware of serpentine windings. And so instead of having like one coil here and then another coil and then another coil all wrapped like that, you just take one wire and go zoom, 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 zoom in a serpentine fashion that does a similar effect as if you wound the coils individually and then hooked them up in series. And there are advantages to that, both in terms of simplicity and more efficient use of wire. So one of the things I got to thinking about is I haven't done a serpentine wound coil yet, but a serpentine wound machine. If you're going to do that, why not mate it to the window motor setup? One of the problems with the window motor setup, as we'll be able to see in the design part, is it gets kind of complicated because the windings are going past your axle, and it's kind of a difficult thing logistically to put together. Whereas if you could do it with serpentine windings, it would be more simple. And I think it would also make even more efficient use of the wire than it is seen with the window motor. So I don't know if that background or context made any sense, but you'll probably be able to understand it a little bit better when we do the 3D CAD design, which is what we're going to do here, and just kind of think about what the parts are that are going to need to be ordered and how the whole thing's going to come together. So I had fun designing it, and I think I'm going to have fun building it, and really have a lot of fun running it. I think it's going to run pretty darn well. So here's how it's built. Let's start with this first one, serpentine window. And so with the window motor, you have your magnets out on the outside with, say, the north facing out of the screen. And so that's what we're going to do. I think the very first thing we have to do then is decide what magnets to use. Now, because with a window motor you don't have a ferrite core or anything with your coil, so, and also because of the particular arrangement of the coil, there's not a lot of interaction. There's not as much interaction with the coil and the magnet. I guess I'd just say that we're going to use stronger neodymiums in this case, and that's a good thing, except for they're more expensive. So let's just start and pick our magnets. And I think I'll make the thing about 4 inches high, and I'm trying to decide whether to make the magnets a 1/2 inch wide, 3/4 inch, or 1 inch. It'll be more simple to make them 1 inch, so that's probably what I will do, unless they have a special or something on some of them. Now, because we're going with neodymiums, they're way stronger than the ferrite magnets we've been using in recent experiments, and so we don't need to go overboard and make the thing like 1 inch thick. So let's just see what they have here. I like this K&J Magnetics. I've gotten a lot of magnets, neodymiums, from them previously. We'll go with block, rectangle, and square. We want rectangle. So we want to look here at bar magnets, and we can see they've got 153 of them, which is nice. And they have a good interface here like DigiKey to let you select on a lot of parameters. So what we want, the length is greater than 2, or I hope this will let me select both. Yeah, I think that'll work. So here, if we go with all rectangles that are 4 inches in length, we're down to 9 results. And the one that I think, while expensive, will not be like absurd, is this one, 4 times 1 times 1/8 inch. And that's still, I mean, it's got 32 pounds pull strength. You know, you could go with something like this, 159 pounds of pull strength. A, it would just be scary, and B, you know, it's like maybe you just buy a new car or something instead. Not quite like that, but it would be expensive as heck. So back to Tinkercad. So just real quick, I mean, these are 1 inch circular magnets, and there's 8 of them. And so that's sort of the spacing there. So I could go with 6 and save a little bit of money. Let me see what, that would be the spacing between that one and the next big one, 6. So just to start eyeballing this, here's something that's the size of the magnet that we just talked about. So let's get that, do something. Oops. So I don't think I'll use this octagon shape just because it have a little bit more wind resistance, but just to kind of illustrate the idea. So you put the magnet, you know, in like that, have it centered on the there, and say the north is coming out of the screen, then you would rotate this, and I think it's 22.5. Oops, wrong one. So if you have this one north facing out, then this one would be south facing out, and then you go around the periphery there. So if we think about this for a moment, if you were going to make a window motor out of this, you would have a line of wire following the arrow like this, and then it would go over the top. There'd be the axle there, so you'd have to go around the axle. Then you'd go down, the current now going in the opposite direction. So if this is north facing, the one on the other side would be south facing out. Down, then you got to go underneath the rotor, around the axle, back to here, up, around, and then you do the same thing for another coil here, and then the same thing for another coil there. And the problem that I think makes it very complicated is you're going around the axle, and you're going over, and then you're going under, and then you got 3 of them. So around the axle, just there's a big mess there that you gotta, be very careful with. So what if you do this instead, which should be the same idea? You go up north with your wire. Now instead of going around to the other side, you go over, and now you go the opposite direction, and again this is south. Now if you just then brought the wire back around to here, you would have a coil. Like a conventional kind of coil, except for it'd be oblong. And that might be the first thing that just to get it running. But you can see that what you could do is go north, boom, down. Now instead of going back this way to complete the loop that way, you go this way, up, down, up, down, up, down. Now you're right back where you started. Boom, you start your second winding. It's just one gigantic winding all around in a serpentine form. And I think it would be a lot easier to build than wrapping this thing around, going through the axle and whatnot. It would just be easier. So that's the idea, the Serpentine Window Motor. Now, could be built like this, but I think I'm going to, as I said, use a completely circular rotor, so to have a little bit less wind resistance. So here we have 2 different circular ones. This one is 5 1/4, 5 1/4, and that should be 5.25. 5.25 also. That one's 5 1/4. That's the same size as the rotors I've been spinning. This one is a little bit bigger, although I screwed that up too. 5.75. 5.75. So this one would be a 1/2 inch bigger. And while these are 4, you notice we made it 4 1/8 inch tall, so that there'll be an 1/8 inch, still on the bottom there. And so how are we going to do this? And I'm going to make both of them, just kind of eyeball it, see which one I like more. We'll start with this one. We said that there's going to be 8 of these. So we take this first one, we put it here, and we align it to the top. Now that I have that, let's get rid of these. Come on, make more of those. Okay, what I actually did also here, even though the magnets are going to be 1 by 4 by 1/8, this is going to be the slot that they fit in. So I gave it an extra 1/100th of an inch and an extra 1/100th of an inch that way, so that the magnet will be able to slide into the slot. So the way this will work is line that up, and the grid is set to 1/8. So if we do one, yeah, that's the idea. One like that, and then make sure everything's lined up. It still is. Then you would hit kaboom. But before we do that, we want to turn this into a hole. Okay, now we do the same thing. Come on. Okay, so we have that there. Now we say, what do they call it? Union group. And now we've got a hole there. And you see at the bottom it doesn't go all the way through. There's an 1/8 inch on the bottom there. So if this were your magnet, you would take this and slide it in there. So now we want to make those all around the periphery, and we're going to have 8 of them. So 360, it's 45 degrees. So we take the next one here, and we kind of just do that, and just make sure that it lined up correctly. Now it's lined up correctly. Now we rotate 45 degrees and do another union. Okay, now we got 2 slots, so I'll finish that and get back to you. Okay, so now we have all the slots for our neodymium permanent magnets put in, and you just drop them in there. Now, the reason why I made the other one, which is a little bit bigger, is, you know, you think about this, the wire is going to be going perpendicular, and per Oersted per ampere, if current's flowing there, this magnet's facing out this way, it drives it at a right angle that way. So that's good, but do we have enough space between the magnets? And we don't want to overlap, so we're going to want the coil to be the same width as the magnet. And what I want to do now is just get an idea whether those things are going to step on each other's toes. So boom, boom. Now rotate this one 22.5, which is half of 45. What do we see? We see there's a tiny bit of overlap. So it would still probably run fine, but that tiny bit there is going to be working at cross purposes. So I got to do the same thing, but with this slightly bigger. And you don't want, I mean, I don't want more space between there, because otherwise you're just kind of wasting wire. But I want them spaced a tiny bit further apart. So close but no cigar. So just to make that really clear, like when you are at that point on the rotation, if the current is still flowing, and it's all going to be flowing in one direction there, that's going to be pushing this one this way and pushing that one that way. So that part and that part would be working at cross purposes. So you want it all, you know, pushing and then off, and then everything pushing in the same direction. So now we got this 1/2 inch larger one. Let's do the same thing and rotate this 22.5. Yeah, that looks just about perfect. So that's about as close as you can get those magnets together without stepping on each other's toes, and you're wasting the least amount of wire. So again, you can see how that works. You just drop the magnets in there and they rest on the bottom. They're not going to come out this way, they're not going to fly off the top. You don't even need to glue them in. Then you can just take another magnet and pull them out if you want to repurpose them for another machine. Now we need to put in a hole for the bearing, and I kind of just always use skateboard bearings. 22 millimeters, I want to say 0.87. I should have it memorized by now. 22 millimeters, 2 inches. 0.866, yeah, and you use 0.87, it fits in snug. So this will be 0.87. 0.87. Want to make sure to give it as many sides as possible, so that's good to do. And 4.125. Yes, so now we do this. Boom. Boom. See, that goes through, the other ones don't. That is where the bearing will go. And boom. So you put a bearing in at the bottom, put a bearing in at the top so it doesn't want to wobble around. And this is all you would need to spin it. But there's a couple other things that we want to do here. The first is, you might have saw the video about adding mass to a pulse motor. And so we want to have a little bit of flywheel mass, and we'll again use pennies for that. And it'll be kind of nice this time because the pennies will be in here. You know, they're not moving in relation to the permanent magnets. The coil will be out here, so there should be a bit more space between the coil and the pennies, so we don't have to worry about any interaction between, well, much interaction at all between the coils and the pennies. So we want to put in pennies for mass, and then there's a second issue as well, because we're going to have to design the scaffolding. That's the other thing that we have to do. But when it's done, you're just going to have one coil all the way 360 degrees around, and you're just going to slide that thing outside of this. If you do that, there's no place if you want to have generator coils or pickup coils. So how will we handle that? So we'll extend this up, and this is going to have to be done in a second part, and then you attach a second part of the same size, and then you put your magnets in. I'll have those facing upward and downward, and then you put your pickup coils over there. The other thing that does for you is once you have a 360 coil out around here, where do you put your Hall effect in order to get the timing? I mean, you could try and put it like above there, but that's not where it's supposed to go. So you would want the Hall effect out here, except for the coils out there all the way around. So you extend this up, you put in some more magnets that are aligned with these, and that's where you have your generator coils, and that's where you have your Hall effect. So there's still a lot to do, and let's just see what we can get done here. So the diameter of a penny is 0.75, so we'll make it 0.76 inches, so the pennies can just go in there. And this is 4 1/8. We need them to rest on the bottom, so we make this 4. Now I want to do one other thing. If we put the hole there for the pennies, and you put all the pennies in, they can get wedged in there. And then what do? You're out like 20 cents. And you're stuck with all the pennies there. So I want to put a hole in the bottom and the center of this so that you could take like a little screwdriver and just push them out if they're wedged in there. So that's what this is. And then we need to align this, and we need to move this up 1/8 of an inch. And that looks like it just moved up 1/8 of an inch. Now we need to get these aligned. Outstanding. That looks right to me. Now we merge these, and just to kind of eyeball it, we put something in there like that, and then you can see the pennies will rest on there, but you can get them out if they get stuck. Okay, so now we've got some space there. If you want to add mass, you can just dump some pennies into these holes. Now if you wanted, there's even enough space to do another layer around like that, and pretty much then the whole thing would start to be mainly copper, or copper and zinc. But 4 inches, I mean, I think about the size of a regular penny roll, and we fit 16 around here. So you can think of how much a penny roll weighs in your hand, and if you use all of them, there's going to be 16, so that would add a fairly hefty amount of mass to it. The other reason I don't want to, whoops, what's going on? I don't want, darn it, to get too close in there, is we need this to extend this upwards in order to put on a place where we're going to put the other magnets for the pickup coils. So the trick is we're going to have to do it in 2 parts, because otherwise you have overhangs. So rather than show every last part, this for the rotor is about what I've come up with for the whole thing. So you have your magnets out here for the window motor part. You have some slots to put in some mass there, and because the coil is going to be taking up the whole outside, you put this part on here, and you got those, and then you have this part here, and you see those will slide over that, and then this part will go in there, and you'll put your magnets here. And you can see that this is lined up with this, and so when that fits in there, each of these magnets will line up with one of these. So in other words, this is also going to be where you put, you put a generator coil there or there. You could put 4 or 5 of them in, but you have one slot empty, and that's where you put the Hall effect sensors. So this is where you put generator coils, and it's also your timing wheel for this, so that you have a place to put the Hall effect. So let me just move this up and see if we can kind of look at how it'll be when it's put together. And you have to do it in 2 parts like this, because otherwise you have an overhang. You can't just print off the edge of the cliff. It ends up like Wile E. Coyote. So when it's all put together, it'll look like that. And this is those magnets for spinning, these magnets for the timing, and for your generator coils. So it's almost there. The last part is going to be the scaffolding for the coil that wraps all the way around here. And I'm going to have to think about that one for a little bit, and then I'll get back to you when I have something that I think might work. So I just sort of superimposed an octagon on there. And from here I think I have an idea of how we can do the scaffolding. So you want your wire going like that, and then over there, and down like that, and then up there. And how big this octagon is going to determine your air gap. So I think the first thing, I'll just have one regular loop coil right there and get an idea of what kind of spacing I want for the air gap. Now there's not going to be a core, so you probably are going to want a pretty narrow air gap. But let's say that this piece here is a hole, so you just put a hole there, and then that gives you the place to run the wire. So I'll put it together for you, and I think you'll get what I'm saying. So now I think you can kind of see the idea. So you'll take your first wind, you'll go up, up, up there, over, down, down, down there, over, up, down. Then you get right back to the start. Now there's a little bit of wire there, so you're a little bit further here, and then there, until you've put one layer here, and then just put multiple layers. This is, I think, I don't know, like 1/4 inch. I might make it more like a 1/2 inch. I think eventually you're going to be too far out from the magnets. But that's the idea. And then you slide that, once it's done, you slide it right in there, like that. And you've got turbo power. That thing will probably fly. Now again, it might not spin at all. You have to build it, but I think that it's going to be pretty darn cool. And again, if it was a window motor, you would take your first one, you'd go like this, and you'd go over there. But the problem is, I've got this big honking thing there, but even without that, you still have the axle that you got to worry about. And you just do the one wind, and then you do a second wind, and it's got to dodge the wire that you put on the first wind, and so on and so forth. It's just more complicated. This way you just zoom, 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 and you should get the same thing. And I think it'll be a lot easier to wind and things like that. So that's where I'm going with the serpentine coil. And again, as we talked about, you put this part up top there for the timing and the pickup, the timing and the generator pickup coils. And you'll need a little bit more of a gap between the stator and the rotor. It's like 1/100 of an inch or something right now, so gap will go about out to there. But that's it, kids. There's 3D printed Serpentine window motor, and I guess you can kind of see where my thinking was on all this and why I'm kind of excited about it. It's going to take a while to order the parts, and the magnets will be kind of expensive. And then the copper, copper's through the roof now, so that's kind of expensive. So if you want to support me, you can pick up one of those 2 Amazon booklets that I have. One on vitamin C and cancer, and what's the other one on? Ah, yes, colloidal silver as an antiviral. Now, why would you want that? Um, I'll probably do another one of those pretty soon. I'll probably do one on fluoride or something like that. So if people are interested, I think it's beneficial for them to learn, and it would help offset some of the costs of the rotor. But in any event, I very much appreciate your support, and you can always support by clicking like or whatever it is you're supposed to do. Click like or something like that, and subscribing. Those are the two things. So there it is. Ain't she purty? Okay, keep smiling. I'll talk at you again before too long.